Hello everyone. In this lesson, we will look at calculating volumes in 3D Scan. First of all, let's import the file I prepared for this lesson. Let's specify that the cloud will be imported into the project in meters. The other parameters remain unchanged. Before we start calculating volumes, we need to build a tin surface. For this, in the 3D Scan tab in the Meshes group, use the Creating Tin command. In the field Build Boundary from Convex Hull, we will set Yes, only external boundary. Yes, max edge units. We will change to length unit, and the value of maximum length we will set to 20. Let's not forget to disable normal generation, break for optimization, and create an additional layer for the mesh. Confirm the parameters and create the mesh. Let's now use the calculation of the volume inside the contour command in the Texturing and Calculations group of the 3D Scan tab. There are three calculation options here: total, differenced, and balance. Total volume calculates the total surface volume. Differenced volume calculates the volume of cut and cover. Balance volume calculates the difference between the cover and cut volumes. For this heap, let's calculate the total volume. In order not to waste time on contour selection, we will specify No in the Define Contour field. We will not change any other parameters and calculate the volume of this heap. The information specified in the Type of Calculation field can be found in the model space. Additional information can be located in the command line. Similarly, we can calculate the volume of the heap using other types of calculations. Calculating the differenced or balanced volume will calculate the volume of materials relative to the project's plane, which is represented by the grid plane in the drawing. Now, let's see how the area calculation command works. We will specify the contour by setting the selection parameter. We will not change the other field values. The calculation results can be seen in the command line. Let's now look at a very interesting example to calculate the volume between models. There are two scans here. One was taken at the beginning of the year, and the other was taken at the end. We will import the first scan, which was taken at the beginning of the year. In the settings for importing text files, we will specify a delimiter so that the result will be shown correctly. In this case, it is necessary to specify the separator, space. These scans are the riverbed, with the help of which we can calculate the difference between the volumes. Let's give a name for this point cloud, Point Clouds number 1. After that, let's import the second cloud, which will be imported also in meters. Let's clip these clouds a little bit. Now let's create a tin surface. And in the Build Boundary from Convex Hull field, we will specify Yes. For the Only External Boundary field, we will set Yes, max edge units. We will change it to length unit with maximum length 40. Let's also not forget to remove normal generation, break the network for optimization, and create a new layer. After that, give a new name for the layer Tin Surface. Now let's hide both the cloud and the network. Let's create a tin surface for the second cloud with similar settings. Now let's turn off the point cloud layer and turn on another tin surface layer. Now we need to call the Calculating the Volume Between Models command. Let's specify the mesh that we created last as the plan mesh. I have already selected it in advance, and it will be automatically specified as the plan mesh when the command is called. We will specify the surface we imported first as the actual surface. We have to change the calculation type to differenced and perform the calculation. Our surface is colored according to the way we specified in the panel on the left, and the calculation itself appears in the model space. With the help of this colorization, we can visually view the changes in relief. At this point, our lesson comes to an end. Thank you for your attention. See you in the next lessons.